Greatest common factor. I can find the greatest common factor. Draw your line down your notebook, and I want you to write this question. What is a factor? You should be able to answer that question in one word. The book, however, tells you it's numbers you multiply together to get another number. The one word you know is just fact or facts. 2 and 3 are factors of 6. They are the facts that make up 6. Another factor or factors of 6 are 1 and 6. So what we're going to do today is start by listing all the factors of 18. You can list them out this way, or you can do it the way I like it, which is in a T-chart. So I have my T-chart, and I have 1 and 18, 2 and 9, 3 and 6. Those would be all of your factors of 18. So what we're going to do today is look at the greatest common factor. And I want you to stop the video so you can get this written in your notebook. It's the largest factor two numbers have the same. All right, so we're going to look at finding two numbers, common factors, that they have the same in 18 and 30. So let's make our T-chart again from the other side. And you can just use the one you already have, but you had 1 and 18, 2 and 9, and 3 and 6. So now let's do 30. 30 would be 1 and 30, 2 and 15, 3 and 10. 4 does not go in. 5 goes in because it ends in 0, so it'd be 5 and 6. There are your factors of 30. So now what you have to do is find the one that they both have in common that's the greatest. So we go through them. They both have a 1 in common. They both have a 2 in common. They both have a 3 in common. They both have a 5, no, but they both have a 6. They both don't have a 9 or a 10 or an 18, 50. So the largest common or the greatest common factor they both have is 6. I want you to stop the video right now and find the greatest common factors of 6 and 21. When you have it finished, check your answer by starting the video again. All right, welcome back. Let's take a look. So the greatest common factors. I first have to find each of the factors. So that'd be 1 and 6 and 2 and 3. In 21, it would be 1 and 21 and 3 and 7. Okay, so now let's find what they have in common. They both have a 1 and they both have a 3. It doesn't matter which side of the T-chart, just that it's there. So the greatest common factor of 6 and 21 is 3. So that's the way you've done in the past. Let's use our new method of prime factorization. Yes, that's making the trees. So we start by making a tree for 42, and then we're going to make a tree for 56. So stop the video so you can make your tree. All right, I'm going to divide 42 into 6 times 7 is 42. 7 is prime, so I circle it. 6 can be broken down to 2 and 3, and then I'm going to circle both of them. So now this is a 2 times a 3 times a 7. I'm going to write them out in expanded form. So let's do 56. Well, 8 times 7 is 56. 7 is prime. Break down 8 into 2 and 4. 2 is prime, so I circle it. 4 gets broken down into 2 and 2. And I circle those. So now this this prime factorization in expanded form is 2 times 2 times 2 times 7. So what I'm going to have you do now is make a Venn diagram. A Venn diagram is two circles that overlap. In a Venn diagram, this side represents the number 42, and this circle represents the number 56. But what we're looking for is just what they have in common. So let's look. This one has a 2 and this one has a 2. So I want you to cross them off because they have 1, 2 in common. It's not two 2's. They have one set of 2's in common. That's it. They don't have any more. But they do have a set of 7's. So they each have a 7 that's in common. So what's nice about using this strategy is now that's all I have to do is go 2 times 7. 2 times 7 equals 14. The greatest common factor of 42 and 56 is 14. And I never had to make a list of all of their factors. So why don't you try 18 and 27 and then come back and check your work. All right, welcome back. So here we go. 18. I would do 2 and 9 and 3 and 3. So I have 2 is prime, 3 is prime, and 3 is prime. 27, I have 9 and 3, and 3 and 3. Okay, so now I'm going to write them out. I have a 2 times 3 times 3, and I have a 3 times 3 times 3. So I'm going to make my circles. Again, I'm looking for sets they have in common. So this one has a 3, this one has a 3, so they have a 3 in common. This one has a 3, this one has a 3, so they have another 3 in common. And then that's it. 3 times 3 is 9. The greatest common factor of 18 and 27 is 9. Here's an example I want you to look at. It's kind of an interesting one. Because what happens when I don't have anything that's 7? 7 is already prime, so we circle it. 15 can be broken into 3 and 5. Now they are prime. So when I make my circles and I expand it out, I have a 7 and I have a 3 and I have a 5. What do they have in common? They don't have anything in common. But every number has one thing in common. They always have one factor in common, and that's the factor of 1. So the greatest common factor of 7 and 15 is just 1. They don't have anything else in common. So you get your worksheet and you can get started. Let me know if you have questions.